All right, hopefully this one will go a little faster now that I don't have to guide you through every single step of the process, and we hopefully will be able to get back into that one proportion z-test pretty quickly here. All right, so Australians back in 1997 were asked if they thought unemployment would increase. 47%, excuse me, thought that it would. And then in November of that same year, they were asked again. 50% of the 630 people surveyed thought unemployment would increase. At the 5% level, so that's your alpha, is there enough evidence to show the proportion of Australians in November of 97 who believed unemployment would increase was more than the proportion who felt it would increase in July? Now, you can't just look at that and go, well, yeah, obviously, duh, the numbers are bigger. Okay, we're talking about, is it statistically significant? Okay, so we talk about, and we'll get into it in upcoming chapters, we talk about like margin of error in polling, especially in our season of elections. That's what we're talking about. Okay, is this statistically significant, or are we still within that realm of possibility that, hey, it's just kind of because of variations in samples? So verify the sampling distribution, or the sample proportion is normally distributed. So again, your questions are, is it binomial? And you should say, yes, it is. Okay, one person's opinion doesn't impact another, and they either think it would increase or they don't. And then we need to check N times P times Q to see that that's greater than or equal to 10. So N is 630 people surveyed. The proportion, again, of the original survey was 47%, said unemployment would increase, and that means the other 53% did not agree. That number is indeed greater than or equal to 10. So we're normally distributed. That means we can use the one proportion z-test in order to do this hypothesis testing. Okay, so write the null and alternative hypothesis. So null and alternative. The null is that the proportion of people who thought unemployment would increase is 47%, and we're trying to find out if a statistically significant number, not 50%, looking at the 50%, if that number has gone up, the proportion of people who agree with that statement has gone up. Okay, so in our calculator, again, you're going to go to that one proportion z-test. So stat, arrow over to tests. P sub 0 is that 0.47. So the percentage of people that we originally surveyed and found out that they thought unemployment would be going up. X is how many people thought it would go up. Now, in this case, all we said was 50% of those 630 people. I have a feeling you know what 50% of 630 is. Okay, so for your X value in your calculator, you need to put 315. N is our 630 people. And then our proportion, it says, is this more than what we thought? So since it's more than, we're going to select the number or the symbol greater than P sub 0, because we're testing whether or not it has gone up. And again, that comes from the alternative hypothesis. So put all of that information into your calculator. Okay, the sample proportion, by the way, we should already know. The sample proportion, P hat, is the 50% of people who thought that unemployment would go up. Okay, and you should get that again when you look at your calculator. The z-score also comes off of the calculator to 4 decimal places, 1.5087. And then the p-value comes off of your calculator as well. So the p-value is 0.0657 once we round to 4 decimal places. And decide whether or not to reject the null hypothesis based on the level of significance. So remember, our level of significance was 5%. Okay, alpha is 0.05. And so what we're looking to find out is our p-value in this outermost 5% or is it not? Well, if you look at our p-value, it is 0.0657. It falls over here, okay, to the right of that like bad zone, if you will. Okay, so in this case, it is not that unusual. Okay, remember we say under 5% is considered to be unusual. This is a 6.5%, little more than that chance. And so that is not unusual. We would not reject our null hypothesis. Okay, so what would that conclusion look like? Well, we say we do not have enough evidence to support the claim that more than 47% of Australians, I'm going to say Aussies because it's faster, thought unemployment would increase. Okay. Now, just to make a comparison, state a conclusion at the 10% level of significance. The 10% level of significance. So I'm going to grab a different color here. Let me go for like this kind of bluish color. I'm going to draw on the same diagram. Okay. So the 10% level of significance would be here, okay, bigger than that 5% level of significance. So now we're looking at anything to the left of that, okay? Notice now that our p-value, our 0.0657, where I drew that curved red arrow, that is now in the reject the null hypothesis zone, okay? So in that case, the p-value is in the reject zone, which means less than 0.10, okay? So we would reject it. And so basically what that means is that we would have the exact same conclusion we just wrote, except we take out we do not have and we say we have enough evidence to support the claim, okay? So we have enough evidence to support the claim, and then ... Okay, the rest of it would be exactly the same. The only thing we take out is the do not. All right, what I would like you to do is give it your best shot to work through examples 2 and 3 and 4. I do have a separate video for each of them coming up, but see how far you can get on your own and if you can start making some of these decisions without having to refer to me every single time. But do follow through your notes, okay? Definitely follow through the notes. All right, good luck, gang. And as you have questions, please, please, please post them to the forum.